use energy principles. Now, whenever you say energy principles, yeah, you're being asked about work energy theorem and things like that, to calculate the work done by the frictional force when the 2 kilogram block moves from point B to point C. Okay, now it's been frictional here up until B, and now it's going to move to point C. So it asks us to use energy principles. So in other words, the net amount of work, according to the work energy theorem, gives rise to a change in kinetic energy. And so what is the net work? Well, the net work is the work done by friction against the motion of the body, plus the work done in raising the body through a displacement. And remember that as it raises it, we should take into account the fact that it is moving along a surface, not moving straight up. Okay, and that is going to give me a change in kinetic energy, which is Vf squared minus Vi squared. Okay, now the work done against friction, and now I can start evaluating these things. The mass of the body is 2. The acceleration due to gravity is 9,8. Delta y is 0,5. And the cosine of 180, so let's remember, is 0, 90, 180. Cosine does this. And at 180, cosine of 180 is -1. And so therefore we've got a -1 in there. And this is also telling us that the net amount of work is being done. So we see that it becomes a negative value. And what that work is, all right, the energy that the thing had before is going to, plus all of this energy that we're taking into account now, is going to produce a change in kinetic energy. Now, in this case, a lot of the work is being done against the motion of the body, and so it's not surprising to us to find the final velocity less than the initial velocity. So here now we put in half times 2. Final velocity is 2 squared. Initial velocity was 4,95 all squared as well. Okay, so the work WF, let's have a look at this. 2 times 0.5 is 1, times -1, which is -1, times 9.8, which is -9,8. And that's equal to a half times 2, and that is 1. And 2 squared minus, so that's going to be 4 minus 4,95 all squared. I think we had a value for that earlier, didn't we? 24.5. Okay, it doesn't matter. So therefore, WF, the work done against friction, is going to be minus, it's going to be plus, it's going to be plus 9,8 plus 4 minus 24,5, and that is going to be minus 10,7 joules. So the work done by friction against the motion of the body is minus 10,7 joules. Okay. Right, let's move right on.